So, in getting started this morning, what we have with us is our senior robotics specialist, Mr. Bryant Henderson, who is going to be leading the presentation this morning. And I will go ahead and let you know that we are doing this webinar this morning from ACS's Automation Lab. When we change over to the live camera in a moment, this lab is available publicly to our sales staff. So it is highly possible that the lights could go off in the middle of the presentation, or you might see a mobile robot running around as our staff logs into the room to be able to show remote capabilities. We did not turn those features off this morning, just to further enhance what we're able to do and achieve. So also, that's going to be kind of conversational. Bryant and I are going to be working together to make sure we field questions. If you have a topic you want to make sure we cover or a question that comes up, please post it to the chat room. I'll make sure to work with Bryant and we will get those answered to the best we can. And I think that's the end of the housekeeping efforts, isn't it, Bryant? All right. Well, Mr. Bryant Henderson is going to take you through from here.
All right, guys. Well, first of all, I just want to thank everyone for being here this morning. Like Cale mentioned, I'm one of our robotics engineers, and I've been working with the UR robots and all of our other automation equipment for about 3 years now. So I've seen a variety of applications. And what we're really going to focus on today is some of the options and functionality that you monitoring the robot through a remote HMI. So like Cale mentioned, at the end of the day, this is to benefit and educate you guys, our customers. So as there are any questions, please feel free to post them to the chat or raise your hand, and we will be sure to get them addressed. Just for an initial introduction, some of the equipment that we're going to be using is a UR16 E-Series robot. We're using a UR. It would be identical for any UR robot model, the 3, the 5, or the 10. We are also using the Opto 22 groov Epic industrial controller. And then additionally to that, all that is required is an Ethernet connection between the robot and the groov Epic controller. Some of the software that we're going to be using today is the Polyscope 5.8 programming software. This is the UR certified software to run on the Teach pendant. This is only running locally on the UR controller. We are going to be using Node-RED, which we'll touch on a little bit later on, to dashboard and Modbus server commands. And we're also going to be using groov to develop the web-based HMI. And then I touched on it briefly earlier, but the theories that we're really going to be focusing on to get this are the control and communication through both the dashboard server and the Modbus server. Over here on the chart on the right, you can see a basic overview of how the UR accepts external commands to control the robot. So without any further ado, I'm going to log into our remote demo to show what this web-based HMI looks like to initially get it running, and then we'll go into some of the configuration settings and what it really needs, excuse me, to function as we're showing here. So I am going to go into a web browser. So I mentioned earlier this is web-based, so this groov Epic is on this IP address on our local network. So I'm able to log in and see my interface through just opening a web browser and going to this address. So let's say I want to go into the initialization screen. Here I have pretty much all of the real-time functionality that you could that would make sense to operate the robot in a traditional industrial environment. So let's say we're getting started from scratch at the start of a shift and we want to run the robot. So first I could power off the robot. You can see over here our robot state is 3, so we just powered off the robot here. And I've got the teach pendant sitting next to me right here, so I can see that, yep, the robot is powered off now. If I wanted to power on the robot, I will send that command. We can see the robot is booting up currently in our indicator there. Now it is idle, so I want to release the brakes. The program that we are going to be running today is called groov, so I will just load that program. And here we can play the robot. And as we go to the login screen, we can see the robot running. We'll go into a little bit more fluid video so you guys can see the application running in just a second. But while we're on the interface, I'll show you a few other tabs as the robot's running. Just working our way down, initially we have the I/O monitor. You can see all of our digital outputs and inputs on the robot controller. These are controlled by this light. So say I want to turn on digital output 5, that light can then come on. Coming back here to our main screen, could go into program data. Here we can see a lot of the key performance indicators for our current run. Right now the robot is going to run 8 cycles because I told it to run 8 cycles. You can see our previous cycle time. We could stop the robot from this screen. And we can also use some real-time safety commands to unlock protective stops, restart our safety circuit, or any functionality that would make sense based off of the current situation the robot's in. Coming over here to trends, we can see some trend data as an example of how you could format some SCADA analysis tools based off of your previous cycle time, the emergency count over a certain amount of time. You could download these files to see it. And we'll go into configuring some of these tools later on. Again, just showing everything that's on the interface. So we can explain the demo. I'm going to allow Kale to take control and share the webcam. Okay, so if I, give me 1 second. All right, so if we go to play our program, what we have going here is a vision guided pick and place. So we have a Cognex Insight 7802 camera mounted on the end of the robot arm. That is taking a picture of the USB key in this area, and based off of the angle that the USB key sits at, that coordinate is sent over Ethernet from the camera to the robot, and it will go pick up the USB stick. We'll wait for the program to run its next cycle just so I can talk through it. We can see here the robot takes the picture, picks the part, and what we're using here is a spiral search routine, which is a built-in add-on from Robotique's Force Copilot. Essentially, the analogy I like to use is if you've ever inserted your key into a lock and you don't know exactly where the hole in that lock may be, the robot essentially is looking for a drop in force to know that it has inserted the key. So using force, we insert the USB key into the dongle, and then the robot runs a random second generator to rotate around in the area and drop off the USB key after it has ran for that specified amount of time. So if I come back into my interface, I know you guys can't see my screen, but I'm just going to run one other demo real quick. So I'm going to stop the robot, and I am going to run another demo to potentially pick gloves up. So there is also the ability on this interface to go between multiple programs. So I have now told the program, in the spirit of COVID-19, to come over here to this box of gloves, apply force downward until it feels the gloves, pick them out, come over here until it feels my hand, and then release the gloves. So an example of how you can go back and forth between multiple programs, all from the remote interface. So, Kayla, if you could potentially give me control to share my screen again. Thank you very much. Again, if anybody has any questions at any point, please feel free to post them in the chat or just raise your hand. You can see back on the interface, here's the grab gloves button just down here that I clicked, and then the robot ran the other program. So back to our hardware overview. I mentioned very briefly that we are utilizing the Groov Epic controller. The EPIC stands for Edge Programmable Industrial Controller. The Edge really provides its value in Groov's ability to communicate to at the edge of the plant's network. So as you need to pull in data from other sources, be that on the web, wherever it may be, variety of industrial equipment, the EPIC is extremely efficient in parsing out data and then communicating to your traditional machines and industrial equipment, but also tying in some more non-traditional hooks like database interaction and a few other functionalities like that. Some of the programming interfaces that are supported by the EPIC controller can be seen up here in the upper right. Today we're focusing on Groov View, and really what is powering our Groov View is the Node-RED interface, but you also have control to program via these other protocols as your specific plant integration dictates. Another thing that is unique about the EPIC is the simple web page development interface. It is mobile friendly, and we're going to spend some time a little bit later on going into the interface that we just showed and showing how some of those buttons and gadgets are configured. A brief overview on the arm. Again, this is a very 30,000 foot view overview of the collaborative robot in the EPIC system. The UR robot has embedded force sensing, which makes it inherently safe. This embedded force sensing also allows us the option to go over some more difficult applications, kind of like the USB insertion that we just showed, potentially picking up those gloves. It unlocks and simplifies a lot of these applications that with the traditional robot, moving between fixed positions would be close to impossible to program. Another major differentiator of the universal collaborative robot from a lot of other traditional robots out there is the intuitive programming environment. That is the polyscope interface that is running locally on the UR controller. It is a visual flowchart-based programming environment that programmers of all levels are really able to pick up quickly. Another thing you get without the necessity for safety guarding is the ability to flexibly deploy these robots as it makes sense on a given day. That's where this interface makes a lot of sense, as you need to change over robot programs, you need to change installation. It's just a matter of physically moving the robot, loading in the right configuration settings, which we can do remotely, and then hitting play. And finally, one of the other major value benefits of UR is the ability to add in UR cap drivers from certified third-party developers. So add-ons like the Force Copilot from Robotique we mentioned earlier. In this example we have over here on the right, there could be an add-on for the vacuum gripper. There is also an add-on for the 3D bin picking solution, which is just a driver that you install on the robot controller. This system over here on the right is actually our ActiNav system, and this is a 3D bin picking solution we're going to be launching in the near future. So stay tuned on that. Kale, do we have any questions thus far?
Yeah, Bryant, we've had a couple come in already. Some of these I've already been answering, but just to bring everybody in the group up to speed, is that we were asked to be able to provide access to some of these third-party softwares. I can definitely make that available. If I've got a couple of emails already, but if anyone would like a copy, please email info, I-N-F-O, at acs-ga.com. Just send me a request you'd like information on the third-party softwares, and I will send you the links accordingly. We also had one request to be able to share the slides of the presentation. Same thing there. Send the email to info@acs-ga. I'll be happy to get that over to you as well. The other things I will be letting you know about, as I said earlier, this is a little bit of a teaser. A little bit of a teaser of a new product that we do have coming out that ACS is preparing to launch to the marketplace in the next coming weeks, so please stay tuned. You may have already seen an Easter egg in some of the slides so far as to what that's going to be. So we are going to be making the core part of this HMI environment available as a utility that you would be able to build off of. But we also offer the capability, and Brian can correct me if I get this wrong, to be able to customize these HMI screens and commands to fit a variety of applications unique to your own environment. All right. We also had another question come in about, and Brian, I'm going to ask these two questions and then let you answer. The ability to control this from any browser, would a mobile device be able to do this? And also, can you, the last one I'm going to go ahead and answer, the ActiNav. That is the new random bin picking package coming up from UR. We will be having a webinar on it in the coming weeks. We're waiting for the formal launch event, but we're starting to talk about it now to start getting the interest. So if you've ever had the need to do random bin picking, please stay tuned for when we launch that. But Brian, could you speak to the ability to control from the browser and the mobile devices?
Sure. So that's absolutely an option. any device that is HTTPS compatible is an option to run this interface. So today, once we go back to the webcam after we finish up the next few slides, I have the interface running on my Surface tablet, my iPhone, and my Lenovo PC using Google Chrome for each one. So yeah, that is an option. And then just touching on one of the earlier questions, yes, this is very much customizable from the graphics to the commands that we add into the program and to the data that we take out of the robot. So this is really just a basic template that we have as a demo in our lab to show what's really possible, but there are a lot of more, call them application-specific features that make sense depending on basically what you're doing with the robot. So coming back over here to Node-RED, I mentioned earlier this is kind of what we are running on the Epic controller for sending these commands to the dashboard server. Node-RED is an open source coding toolkit primarily aimed at developing IIoT applications. So it does a really great job of pulling in data from multiple non-traditional sources and making a decision. So you can see here we have experience in some of these providers on the right communicating with Node-RED, be that Amazon Web Services, RESTful API. Basically what this boils down to is depending on how you need to publish your data based off of your company's policies, there likely is a Node-RED option to publish it. Another thing with Node-RED is it's visual and flowchart based, so you're not looking at a blank screen and having to know the structured text like you would in C# or Python or something. It's basically a flowchart. So if you've ever charted a process flow, it's similar to that. Also, it uses JSON tags for formatting and storing data, if you're familiar with JSON tags. The groov view interface. This is Opto's web-based HMI development page. It has the option to tie into Pack Control if you wanted to, or any of the other, I guess, software packages that we discussed earlier that the Epic is capable of running. Groov view can function as the HMI for any of them. It functions through gadgets that source data through tags. So I'm going to go back to our interface and just go over a brief example of how we would add in a tag or a gadget. So I can go to my initialization screen, and looks like there is a button blatantly missing there that we need a pause button. So if I come over here and switch to my build mode, this is essentially where you could format how all the icons look on your screen. So I want to add in a pause button. So if I come down here to my gadgets and I look at pause, I can click on pause, and then I want to add in a button. So I'll click on button, just put it in there. Maybe we want to make it a little bit bigger. Now we have a pause button. Maybe we want to say when it's on, it's yellow, so we can put yellow for pause. And as simple as that, we now have a pause button. A couple of other examples of gadgets that may make sense. If I come over here to my trends, perhaps you want to see the uptime. How much has the robot been running over the past few hours? So in my gadgets, I have a Boolean that is tied to program running. So if I click on program running, I just want to add in a trend. So I'll drag that chart, put it in here. We'll put the title of the chart. As you can see over here on the right panel, it's going to be where you configure a lot of these specific that gadget. So we'll call it uptime. Let's say we want to look at a period of the past 3 hours, and it's only going to be between 0 and 1, 1 being on, 0 being not running. So I'll make the maximum value 1. So we could drag this around, maybe make it a little bigger. And so now we should have 2 more gadgets in our interface. So if we want to test to see if this worked, I'll just hit Save All Changes and switch to Groove View. So I can go back to my login screen. I want to go to our initialization screen. We'll load the Groove View program again. And then we want to play the program. And the robot's moving. So maybe we want to test our pause button. I just clicked our pause and that worked. So the robot just paused there. We should have some data in our trends too. So let's look at our uptime chart. And right here you can see the program started running at this time and ran for that set amount of time until it stopped. So as you can see, pretty user-friendly and intuitive in how you add those gadgets in. One other thing, maybe we've got a scaler here for our good count. Maybe we want to add a scaler in for our bad count. So the same process of going down here to look at our bad count variable. I'll click on it. What do we want? We'll have a range indicator for our bad count. Click on my bad count. So maybe we want 15 to be our maximum bad count, and we don't really need any decimal points, so I can take that precision down to 0. And if we save, we now have a bad count indicator. So that is just a brief overview of how you can add some gadgets in and operate the interface that we showed earlier. So just to wrap everything up before we get to some questions, I tried to boil down some of the major features that you get in this remote HMI that you wouldn't get through just running the robot locally. So one of the big ones is real-time SCADA analysis. So for uptime, emergency stop trends, cycle time trends over any period of time, it's fairly easy to map that data out and download it as you see fit. Another thing that I have here is program-specific data. So we are not limited to the data that we're showing here. If there are any other key performance indicators for the robot that you would like to monitor, we've got available registers to put that data and display it on this interface. You get a real-time video that is based in the web page, so you can see an indicator, and you as you saw. This is easily scalable for fleets of robots. So we're just showing this with one robot today, but it's just a matter of copy and pasting and putting a different robot on different pages. And then you could potentially send commands to a fleet of robots or select a robot from the fleet and send commands directly to that. Also built in to Groove View is the ability to set security levels and page permissions. So what you get here is engineers can have their own screen where they could potentially format gadgets and make the screen specific to what they want to show. But then you can also have a screen with more limited privileges for operators that would be able to, they wouldn't be able to edit some of these configurations, and they'd just be able to operate, run the robot. Maybe you have another permission level for some type of plant manager or production manager that just is more concerned about the uptime and the data that is being generated on the robot. That's an option as well. Mentioned earlier, this interface is extremely customizable. So although we have the ACS logo and the watermark on our screens, you could customize this to whatever company logo or you'd like to show. You have the ability to change the robot program and installation file remotely. So as that flexibility concept comes more into play, this really simplifies some of that changeover process. Another thing that you have in this interface that no other option other than dashboard server commands gives you is the ability to unlock a protective stop or close a safety pop-up. If the robot did come into contact with something, other than physically going to the teach pendant and enabling the robot hitting play, the dashboard server is the only other option to run the robot. It's a user-friendly interactive web page that functions as your HMI, so it's as simple as getting a tablet with a browser and mounting that wherever. There's no other complex wiring or configuration for your HMI. And then finally, kind of a blanket statement, there is the option to tie into wide-reaching other industrial equipment because of the Epic controller's ability to communicate with a wide range of devices and structure that logic accordingly. So that is pretty much all I had. I'm going to go back to Kale and see if we have any additional questions.
Yes, Brian, thank you very much. Just to highlight a couple things, Brian was able to show a lot of the customization that we were able to do within the HMI part of the screen. But the tag base that you saw him referencing, that is part of the product launch that we are planning to do in the coming weeks to be able to have the mapping, the decision making, the macros, all the behind the scenes stuff already mapped out and done. So that if you're a machine builder, you're a custom integrator, and you want to tie this in with a HMI setup that would be closer to your equipment, your logos and artwork, we would be able to adapt that accordingly to fit your environment, your company, and what's going on with it. So, but all of the tags, the structure, the behind the scenes work, the engineering that's associated with that is going to be done as a product that we're going to be launching in the coming weeks. So we'll keep everybody up to date. The Node-RED training. So a couple people did ask more about wanting to learn more about Node-RED. Node-RED is a open face programming protocol. It was originally developed by IBM, but it's a public language. It is a graphical based JavaScript programming environment. Now we do teach a class on the basics for Node-RED commands. Our next physical class that we have scheduled is going to be later in the summer once we finish getting through the virus situation we're in. However, if this extends, we would be looking to do a remote training scenario with that in some capacity, or at least look at what our options are for it. So please stay tuned to either our website or sign up for our newsletter. Our website is advancedcontrolinc.com. You can sign up for our newsletter there. We'll be sending announcements for it, but we do a hands-on general-based Node-RED programming class. And with that, we actually show how we can communicate to mobile devices, iPads, iPhones, that sort of thing. Brian's going to show you that interface here momentarily. Let's see, it seemed like there was one more. Oh, we did have another question, Brian. Can everything that we've shown, if someone were to work with us to get our new product when it comes onto the market. They wanted to adapt their interface screens. Could they be able to show it and interface with their customers using the UR simulator?
So, can you show it using the UR simulator? If you tied the Epic to an Ethernet connection on your laptop that is running the simulator, all the Modbus server and the dashboard server commands should still function as you'd expect to. So it's just a matter of configuring the robot in the simulator the same way that we have here. But yeah, that should be an option to get an explanation of what the HMI screens would look like, and how you could customize that depending on the end user.
All right, we had a couple other questions come in. One is, could you mute your mic?
Yep.
Is the controls built into the Epic, or was it an interface developed by ACS? It's a combination. We're definitely using the Epic. We're using the IoT capabilities of it with the Node-RED structure that's available. But then ACS has developed the custom engineering to be able to map the necessary communications between the UR and the Epic to get those tags, tag structure, and background programming done to make a more finished product so that you can immediately begin developing rather than starting from scratch. So it is a joint of the two, but the actual UR interface is an ACS product. The other question we had come in, what are edge-based controllers and how are they different from a PLC? So very basic terms, PLC, a programmable logic controller, does an excellent job handling IO status to be able to turn things on and off, monitor IO bits at very high speeds, perform very high precision logical instructions. The edge-based controller that we're talking about is a device meant to live on the edge of your network, be closer to the valves, the actuators, the sensors, to be able to bring data in as close to the edge as possible to then take advantage of the next generation of IoT communications, be it the Node-RED in the case that we're doing here for command and control, or as we get to in other classes, things such as an MQTT server, so that now data can be shared without violating a firewall or without opening your network up to a hacker or infiltration, to be able to get data into and out of maybe a cloud-based server or a remote home office or something like that without violating your firewall integrity. Being able to add the next generation of OPC UA tags. This is the OPC Unified Access. You may also be working with a piece of software referred to as Ignition for that. This has the ability to communicate more seamlessly for the modern generations of PLCs out there. So your Siemens, your Schneiders, your Allen Bradleys of the world communicate via the OPC tags. And we're able to share data into and out of those systems much more seamlessly and easily to be able to do things like just what Bryant showed, the trending analysis and the trending graphs, much easier that we can then send to a mobile device. So being able to have this live closer to the edge of the network, tie in the IoT, communicate to the main PLC, and then communicate out. That's a very rudimentary layman's definition of the difference between the edge controller versus the traditional PLC. We are going to be doing a more detailed Epic webinar that is going to go more over its features in the coming weeks as well. So again, please sign up to our newsletter from our website to stay tuned for that. All right, let's see. I think that's all the questions we have at this point. Bryant, should we switch over to the live camera and show the mobile interface?
Sure.
We're good.
All right. So first I'll show my tablet. As you can see, screens here are still formatted the same as they would be on my PC. If you remembered, when I was in the build mode, I had the desktop and tablet tab here, and then I also had the handheld tab over here. So you can see, sorry, I know it's a little blurry, but you can format the buttons differently. On my phone that I've got right here, you can see the, here we go. You can see this is the initialization screen. We want to go to my initialization and we want to play the robot. So I'll hit play and the robot is playing now. And it's going to insert the USB key. As I come over here, I can see my trends on my phone as well. You can see the camera interface. Could also see the I/O here on the phone. Basically everything is shrunk down a little bit to become mobile friendly. I guess while I got my phone, I can go ahead and I'll let the robot finish up and then we can pause it. Does anybody have any questions additionally on some of the interface?
Go ahead.
All right, I have not seen any other questions come in at this point. So we are wrapping up to the end of our time. So if anyone does have a last minute question they want to post today, please do that in the public chat. Just to make everyone aware, we are recording this. So we are going to be uploading this to our YouTube channel. If there's someone in your organization that you think would benefit, please subscribe to our YouTube channel. Take a look at it. It's going to be available there. Also, go to our website, advancedcontrolinc.com. Sign up for the newsletter to be made aware of the upcoming webinars that we're going to be coming out. We will be talking more detail of Node-RED, of the Epic controllers, as well as the other products you've seen here, such as the Force Copilot, the Cognex cameras, the UR robots themselves. So I've not seen anything else. If you would like to be on the list to be notified when we launch our interface product later, probably within the next 2 months, if you want to be on that notification list to be able to take advantage of it, or for us to be able to reach out and work with you on that, please email me at info@acs.com and just state that you would like or you're interested in Fulcrum. That's going to be the key word. So if you just email me, you're interested in Fulcrum at info@acs-ga.com, we're going to put you on the notification list. Right now, you're the first group that we put the teaser out for of what's coming. Hope you have enjoyed it, learned a little bit, gotten some inspirational ideas on how you're able to work with everything. No more questions have come in, Brian. So I'd like to thank you for your time in setting this up and getting the programming done. And I think that's it for what we have today. Again, YouTube is available, our website's available. Email me at info. We'll be happy to work with you any way we can. Thank you for attending, and y'all have a great day.
Thank you very much for your time, guys. I hope it was beneficial.
Thanks, guys.